My name is Omri Bar. I lead the AI research group here at Theator, working in this field of computer vision for the past 10 years. So straight from the beginning, we understand that we need to focus on three different pillars. One, we wanted to have a very accurate system, one that can run fast on both edge devices and on the cloud, and one that is scalable and can work on many specialties and many procedures. VTN, which stands for Video Transformer Network, and it allows us to still maintain very highly accurate results, but also be able to run on the cloud and on edge devices very fast. Most of the technologies use either specific frames or very short clips. And in surgery, we understand that a procedure will take a very long time. And the context of a short clip is not enough in order to understand things that happen in the beginning and maybe correlated to things that happen at the end. So we looked for a solution that can process the surgical video like in an end-to-end manner, something that can process everything and focus on what is mostly interested, and this is what VTN gives us. An important event at the beginning of the procedure, maybe like a significant bleeding, it might impact the rest of the procedure and how final inspection will look like, and we want everything to be work together in order to get better results. So VTN is designed to do that, to be able to understand and correlate different parts of the video. So in terms of scalability, we understood that we want to reach to as many procedures that we can, and also to different specialties. And to do that, we needed to collect lots of videos and annotate them, which is not trivial and it's a long process. So when we started working, we mainly focused on procedures like traditional procedures like lap chole, and we had hundreds, thousands of videos annotated for lap chole. So the entire technology was in the beginning based on what lap chole can do, and we understood that we need a way to transform or transfer the knowledge that we have from the lap chole model to different procedures inside general surgery, but even to other specialties like gynecology. And to do that, looked at a technology that is not specific to our domain. It's called transfer learning. It's used vastly in machine learning. And we use transfer learning to be able to transform from a procedure that we have many videos to one that we only have like a couple of dozens videos, and it works very good inside general surgery and also in other domains like other specialties. It took us around 9 months to gather all the video and annotate them and develop the technology, but then we only need a couple of dozens of videos in order to train any new type of procedure, and even in domains or specialties that are not looking like the anatomy of lap chole. For instance, in gynecology or urology, the scene is completely different, the anatomy looks different, but the representation or the feature that our model learns enable it to easily transform to other domains with only like a very few tens of videos. The main concept is taken from autonomous vehicles in which we have multiple cameras around the car, and the system in the end need to understand what happened in the entire scene and predict several tasks, like if there is a pedestrian in front of me, the curves, the stoplights, and etc. And we understand that in our domain there are a lot of similarities, like we want to predict if the camera is inside the body. So we want to take all the inputs that we can get from the video, from the metadata, put them in a specific network and predict everything that we can on top of that video. Other than that, if we want to go to minor procedures, those that happen rarely and rare events that are in the tail of the distribution of procedures. So we want to be able to take the knowledge that we have from the vast volume of procedures and then use it in other places. And when we train such a multitask network, it learns from the entire database that we have, from procedures that happen more, less, and rare events, and then we can use that system to work on the entire surgical domain.